Hello everyone, we are from Group Palladium PD, and today we are going to discuss about electrochemistry and application. Redox is short for oxidation reduction reaction. Oxidation can be determined by several terms, which are gain in oxygen, loss in hydrogen, electron loss, and reducing agent increase in oxidation number. And for reduction, it can be determined by loss of oxygen, gain of hydrogen, gain in electron, and oxidizing agent decrease in oxidation number. Oxidation number is a system that we can use to keep track of electron transfer. General rules, elements by itself is equal to 0. For example, Br2 and Cl2 will equal to 0. But for groups, group 1A is always 1 plus, and for group 2A is 2 plus. But group 7A is usually minus 1. Hydrogens can be determined by two terms, which is if it's with non-metal, is plus 1, but if it's with metal, it's minus 1. Oxygen is usually minus 2, but it is minus 1 in peroxide, and fluorine is always minus 1. Electroplating. Electroplating is a process where a thin layer of metal is deposited onto a surface of another material using electrolysis. How it works: anode, the metal that you want to plate, such as silver or chromium; cathode, the object that you want to coat, such as a spoon or a ring; electrolyte, a solution containing metal ions, such as Ag plus or Ni2 plus. Electric current is passed through the circuit. Examples and uses of electroplating is for jewelry, such as gold or silver; cars, chrome-plated parts for shine and rust resistance; electronics, gold-plated connectors for better conductivity and corrosion resistance.
Now, we are learning how batteries work using electrochemistry to power things like phone and laptop. Let's break it down. Batteries are devices that convert chemical energy into electrical energy using redox reaction. They come in different types, each suited for specific uses. First, primary cells. These are single-use batteries, such as alkaline battery. Second, secondary cells. This can be reused multiple times, such as the lithium-ion batteries in your phone or laptop. Third, fuel cells. These generate electricity continuously by converting fuel, like hydrogen, making them ideal for long-term power. How does a battery work? Inside the battery, there are two electrodes, an anode and cathode, separated by an electrolyte. When the battery is in use, electrons flow from the anode to cathode, creating the electricity that powers our devices. Now, that we know how batteries work, let's see them in action. Batteries are not just a lab experiment, they are everywhere in our daily life. Here are three perfect examples. Firstly, smartphone and laptop use lithium-ion battery because they are lightweight and portable. Next, electricity vehicle use high-capacity batteries to travel longer distance. Also, power bank use rechargeable batteries to give backup power when needed.
Hi, today I will explain how electrochemistry is used in medical applications. Electrochemistry is the study of chemical reactions that produce electricity or use electricity to make a chemical change. In the medical field, this is very important because many modern devices use electrochemistry to monitor health or power impact. This slide shows how electrochemistry is used in different medical devices to help monitor and improve health. First, glucose meters. These are used by diabetics to check their blood sugar levels. The device uses an electrochemical sensor that reacts with glucose in a drop of blood and measures the glucose level. It helps patients to manage their diabetes. 2. Electrochemical biosensors. The sensor detects specific substances in blood or tissues, such as cholesterol or latex. They are useful for quick and easy diagnosis, often used at the point of care, like a clinic or home. The third one is batteries in medical devices. Many medical devices like pacemaker, hearing aids, and implants need small batteries. These batteries use electrochemical cells that provide steady and long-lasting power, helping the device to work properly for a long time. Example of device. The slide also lists some examples of device that rely on electrochemistry. 1. Blood glucose monitors. 2. Portable ECG monitors. 3. Electrochemical test strip. And the last one is battery power implants. So, electrochemistry plays an important role in making modern healthcare device more effective and convenient.
Now, I'm going to explain the electrolysis process in a simple and clear way. First, what is electrolysis? Electrolysis is the process of using electricity to break down a compound into its elements or simpler compounds. This is usually happens with ionic compound. Now, let's look at the basic setup. To carry out electrolysis, you'll need an electrolyte, which is the ionic substance to be broken down, either molten or dissolved. 2 electrodes made of metal or carbon placed into the electrolyte. One is anode, which is positive, and one is cathode, which is negative. A power supply, which connects to the electrode. During electrolysis, redox reactions happen. Oxidation is the loss of electrons, which happens at anode. Reduction is the gain of electrons, which happens at cathode. Now, let's go to example 1. Electrolysis of molten sodium chloride, and ACl. This is used to extract sodium metal. The electrolyte is molten NaCl. The electrodes are made of inert graphite. At cathode, sodium ions gain electrons and react to form sodium metal. Na plus 1 electron reacts to form Na. At anode, chloride ions lose electrons and react to form chlorine gas. 2Cl minus react to form Cl2 gas plus 2 electrons. The overall reaction is 2NaCl react to form 2Na plus Cl2 gas. Next is example 2, electrolysis of water, which produce hydrogen and oxygen gas. Because pure water doesn't conduct electricity very well, we use acidified water as the electrolyte. The electrodes are inert platinum. At cathode, hydrogen ions gain electrons and react to form hydrogen gas. 2H plus 2 electrons react to form H2. At anode, water molecules lose electrons and react to form oxygen gas. 2H2O react to form O2 plus 4H plus 4 electrons. The overall reaction is 2H2O react to form 2H2 plus O2.
In conclusion is, electrochemistry plays a vital role in modern life by bringing chemistry and electricity. It is essential in numerous applications that impact our daily activity, industry, health, and environments. From batteries powering our device, to electroplating that protects and beautifies metal, to electrolysis in water treatment and metal extraction, electrochemical processes are everywhere. Moreover, medical technologies such as glucose sensor and breathalyzer rely on electrochemical principles to help monitor health and ensure public safety. In transportation, electric vehicle EVs use advanced electrochemical batteries to reduce our dependence on fossil fuel and lower carbon emissions. In summary, electrochemistry is not just a scientific concept, but a powerful tool that enhances technology, improves quality of life, supports sustainability, and helps solve real-world problems.